Hey everyone, my name's Raed. I'm an Android developer here at Tunnelbear. This is my first talk as part of this meetup, but I've been to a few of these before. And I'm going to be talking about secure storage Paw-blems on Android. What do you want to do if you want to store sensitive information like a password or a cookie or a driver's license number or passport information? That's what you really want to do. If you Google store password Android, you get quite a lot of results. So I'm going to talk about a few of them. So you can't read this maybe, but this is the simplest approach. Just store the password in shared preferences. No. Shared preferences is meant for like maintaining state, informational stuff, not actually meant for passwords and driver's licenses or whatever. Just don't do it. This other person said that you could hash it and then store it in shared preferences, but that's also bad because you're still using shared preferences, and it's really easy to get around a hash. All you need to do is reverse engineer an application, for example, to get things like the salt or the number of rounds that the person's using for that hash. Another option is using Account Manager. If you guys are somewhat familiar with that class, it's effectively a central repository for all of the users' accounts across all of their devices. The general idea is that if you log in on one device, you'll effectively be logged in on other devices as well. So some people say, well, just store your passwords in the Account Manager and it'll sync across all your devices. But the problem here is that the developers of this class and the framework have actually explicitly recommended not to use this for storing passwords. What you're supposed to do is actually transform your password into something that's not sensitive, like something like a token, things that can't really be traced back to a password. So don't do that either. This person said the same thing, just use shared preferences. Up there is a code snippet. Sorry, I'm just like hammering all of these images on each other. You're not really meant to read them, but this person also suggested that you should just encrypt the sensitive content, store that sensitive or the encrypted content in shared preferences. But then the problem is, what are you going to do with the key that you used to encrypt that content? You could encrypt the key and store the encrypted key in shared preferences, but that's not really going to work. And this person just suggested that it's just like a tip, maybe don't use strings for your sensitive content and use character arrays instead, just for JVM garbage collection reasons, but that does not solve anyone's problems here. So these are a bunch of different ways to solve this problem, but there's a better way to solve it. Whoops. I did something. And that's the Android keystore. The Android keystore is a keystore, and keystores store keys. Android guarantees that the Android keystore is sandboxed. And what that means is that each application has its own keystore provider, and that any keys that it creates are only accessible by that application and no other application. The Android keystore also has other features like key extraction prevention. What that means is that no one else, like in the event that someone has physical access to your device, no one can actually extract the key material from that device. Even like the application itself doesn't have access to that key material. What the application does is it initiates the crypto operation, and then the actual operation is executed on a system level thread. And finally, there is secure hardware. In the event that a device has things like trusted execution environment or secure element, Android keystore actually leverages it and stores the keys on that trusted hardware. But those are just words, and is it actually secure and reliable? It depends. Android keystore, like a lot of other software, it was prone to bugs when it was first released. It was released about 6.5 years ago with the second maintenance release of Jelly Bean, and it actually came along with two pretty severe bugs. One was in Android 18 and Android 19. The general idea was that there was a stack-based buffer overflow, that effectively leaked the device lock keys and any Android keystore keys, which is absolutely devastating. The other issue is called forgetful keystore, and the general idea there is that in the event that the user changes their screen lock pattern from like a swipe to a pattern to a pin or whatever, any keys in the Android keystore were just lost. And all of these Android developers had to graciously handle all of these problems. If you talk to any developers that use the Android keystore when it first came out, they're all incredibly jaded and have switched to other things. This was awful. It was kind of like a shining light. This is finally like a secure solution that they could finally use, but then these things happen. Then there's also the problem of rooted devices. What about that? With any of the other solutions, when you're actually on a rooted device, it's technically game over. Like shared preferences, any user with physical access to the device can read through that content, but not only that, any application on that rooted device can also read the content of your shared preferences. With the Android keystore, it's kind of similar, but in the event that there's actually trusted hardware on the device, it's a little harder to actually get that key material and actually decrypt the content that you've encrypted. So having said that, why does TunnelBear use Android keystore in its products? Well, quite frankly, it is actually the most secure option that we have for this platform. And we are a privacy and security company, so that stuff is incredibly important to us. We also don't just use the Android keystore. We actually use that in combination with other things like OpenSSL, libsodium, SQL Cipher, and the combination of all of these things really works out pretty well for us. And finally, it's matured really well. It has been 6 years since it's been released, and it is the future in terms of secure storage for Android. But yes, that is my talk. Does anyone have any questions, comments? Yep.
When you say trusted hardware, what does that mean? You were talking about the rooted device. You can check trusted hardware.
Yeah, so generally, trusted hardware is pretty similar between devices in general, not necessarily restricted to Android devices. What that means is there's like a secure chip that is meant for securely handling any sensitive information, and generally has like a set of secure processes that run on it. Yeah, there's like a lot more involved in that stuff. We could talk about it after, but it is like a piece of hardware on a device that is meant for all these secure operations. Yeah.
How do backups generally work with secure storage?
So,
is there any other backup options or anything?
So backup for the device itself.
Yeah, can you back up keys? What are there issues with backup keys?
Well, I don't understand. Sorry, I don't understand what you mean by backing up keys.
So I was previously able to back up apps on Android, especially if you back up everything.
Yeah.
How does the secure storage work with that? I assume you just can't because
Yeah, you can't really back up keys. That's not really a thing with the Android keystore. Everything's stored on the device. Anyone else? Yep.
How do you deal with older devices?
That's a great question. So I'll start with the easiest solution, and that's that we just don't with Remember. The minimum SDK version is now 21, and because Remember, which is our new password manager, since it's a newer product, we don't necessarily need to deal with all of that legacy. TunnelBear, on the other hand, has support all the way down to 16. And what that means is that we have actually two different solutions. One that relies on the Android keystore, and the other that relies on this kind of generation of key on the device and then storing that in shared preferences, which is obviously not ideal, but we don't really know what to do there.
Right.
There's no way to store that
So
key
there's
securely.
no best practice for older devices, really.
Yeah, I think on Android in general, unfortunately, security is something that came a little later.
Yeah.
Yeah, no worries. Any other questions?
What's your experience with safety?
Safety net? No.
So the checks can be rooted.
Sorry?
So you said none? That was your answer?
Yes.
Oh.
Yeah.
Okay. So how do you deal with rooted devices? Is it a problem for you? Or?
Generally, we don't necessarily, that's not our target audience. We're not really targeting people who have rooted devices. Obviously, we want to find the most secure solution for the majority of people. But, yeah, rooted devices just aren't a priority.
For instance, if the device is rooted,
Yeah.
you don't allow to use the app.
No. They're allowed to continue using the application. It's just, it's actually the same experience.
Yeah.
Yes. So, just to clarify a little more, the Android keystore is still available on rooted devices, as well as any of the other solutions that I've mentioned. It's just using the Android keystore does actually have some added benefits on rooted devices, whereas any of the other solutions just don't.
Is it vulnerable at all, the Android keystore, if the device is rooted?
Yeah, absolutely. I mean, if there's no trusted hardware, then what that means is that the key material is not stored securely. And, I mean, a rooted device implies that any application has full control over the system, right? And because of that, they could potentially get access to the key material and decrypt any content that might be sensitive.
When does it get cleared?
Sorry?
When does the keystore get cleared?
When does it get cleared? As a result of bugs, sometimes. Ideally, never. What it's supposed to be is this thing that always exists and you can rely on it. But that wasn't necessarily the case earlier on. But once you do get over all of these hurdles and you resolve a lot of these bugs, which does take a really long time, it's pretty great. Our bugs now are not because of the Android keystore. They're because of stupidity.
Is the keystore tied to any biometric data, like a fingerprint sensor?
It absolutely is, yeah. So with the introduction of fingerprint authentication in Marshmallow, I think it was, it actually works really well. A lot of cipher algorithms were also added in the Android keystore. Stronger cipher algorithms were added, and it works really well. The entire framework works really well with the Android keystore. I said that 3 times, but it's amazing.
Just happened which in the under the developer backstage podcast, they have a whole episode talking about that. If you want to.
There's lots of resources available, and feel free to email me or Arturo for more information on that. Okay.